So, what is a matrix? I believe in mathematics, a matrix is just a group of numbers arranged in rows and columns. So, let's see what Wikipedia has to say about a matrix. So, you can see it's already saying it's a rectangular array or table of numbers or expressions arranged in rows and columns. Now, in programming, what can we compare a matrix to? I know you've heard of 2D arrays. I mean, maybe we can just write something. Yeah, I know you've heard of 2D arrays. And what is a 2D array? A 2D array is an array that contains another array. I mean, let's say, like in Java, we can say that 2D array is initialized by we will call it a matrix by specifying the number of rows that you need. In our case, let's say let's just emulate the one from Wikipedia. We see how it will go. This one, you see, it has 2 rows and 3 columns. So in our 2D array, we will say that we need 2 rows and 3 columns. So maybe we can just print it out and see what it has first of all. So now I in our case will represent the rows. Now we will look through all the rows in our matrix, which is represented by I, and then now to see now the number of elements in each row. For example, like now since we are looping through the first row, now we need to print out now all the elements that are in this row. Now so we'll just loop through the first row again, not the first row but all the rows which is represented by I. So now we will look through the current row. Now we take its length. Now for us now to see the elements, I believe I want them arranged. Maybe we want them arranged. We will first print them in a continuous sequence. We will print out the elements in the current row, in the current column. And then now for us to see them better, I believe we should just skip a line. Oh no, we should add a space between the elements. Yes, and then now, what is this now? Yeah, I believe so. And then now we will have to skip a line for fun. Let's see what's in our current matrix. And then now things you should remember. Now you see the row label. I mean, like the name of the row. I mean, the name of the row that you're in. Let's say in our case here, the first row is represented by 0. And then now you can see in our first row we have 000 and 000. Now the row labels represent the names of the graph, the nodes of the graph. And then now you see the elements in the matrix. Now this is the relationship between each node. Like let's say we had a graph that had nodes 0, 1, and 2. We're just going to write something here. Let's say we had a graph. The graph has nodes 0, 1, and 2. Now you see now we can print out the nodes for us to see them. So now we are going to print out I, and then now then we have something node, and then now maybe now let's just say remember I is the name of the node. Now and also we were talking about things you should remember. It has just done something bad. But you can see now node 0, the first element is 0. And then again in node 0, the second element is 0 again. Now this will be a little bit confusing. But remember the row label represents the name of the node of the graph that we are looking at. And then now the elements in the matrix, now they represent now the relationship between nodes, because now you see if now I is node 0, then now remember also in a graph will always have a matrix that has the same number of rows and columns, because if we have nodes 0, 1, and 2, we will have to see the relationship between each and every node. Let's say even if they don't have something, we will even have something to represent that. Yeah, so like let's say I is node 0, and then J, the, the column that we are at, is column 2. Remember, J represents the column. Now we are at column 2. Now we will have to see the relationship between node 0 and node 2, because the row labels represent the name of the node, and also the column labels, because we have to we have we ought to have a matrix that has the same number of rows and columns for us to represent the information in the graph. Now let's continue. You remember now uh, our first row, which is row 0, index at 0, and then the first element in row, the first row, what is it from Wikipedia? I remember it was 1. So now our first element will be 1, and then the second element in the first row. Now the second element in the first row, I believe, is 9 from the document. And then now what is the third element, which will be indexed at 2, is negative 13. And then now I remember the elements in the first row are over. So in row 2, which will be indexed at 1, the first element, which will be indexed at 0, I believe it's 20, and then the second 5. There's something I believe it's 20. And then now the second element in our first in our second row, I believe it was 5, and then negative 6, something like that. Yeah, now the third element, which will be indexed at 2, I believe it's negative 6. Now if we print out now the elements, let me just confirm. Yeah, I believe it's negative 6. So now if we print out the elements, I believe we should have something. Yeah, I should have added a space. Yeah, now we will now say, maybe let's take an example. If the nodes were cities in a let's say a county, right? Yeah. So if the nodes are cities, now let's say city 0, we can say now the relationship between those cities is the distance. Now we can say the distance from city 0 to city 0 again, it's 1. And then now the distance from city 0 to city 1, it's 9. Let's say something like that. And then let's say now the distance between city 0 and city 2 is negative 13 meters. You can see now we have some information from the graph represented in our matrix, because the row labels in the matrix will be the name of the nodes in the graph, and then now the elements in the matrix will be the relationship that we decided to give them. Yeah, maybe we can see a real life example, and then we see how we will write the array.